All right, so with projectile motion, you are always going to, well, not always, most of the time you're going to be given a velocity. And from what we just learned with vectors, we know that we can break that velocity into its components, its horizontal component and its vertical component, by taking its magnitude, the initial velocity, that's what v sub 0 is right here, okay, that's the initial velocity. We take that and we multiply it by the cosine of the angle, we multiply it by the sine of the angle, and we will get the horizontal component versus the vertical component. You have to split them apart. Now, the path in parametric form, they will always take the horizontal component and you multiply it by t. All that is a derivation of distance equals rate times time. Okay, distance equals rate times time. That's all the horizontal component is. So your rate is your velocity, but just the horizontal component of the velocity times your time. The y component is a little bit, or the y part of the parametric equation is a little bit more involved. It all has to do with the force due to gravity. That's where the -16 comes from. That's when it's in feet per second. And then you see you have your velocity, the vertical component of your velocity times time, and your y sub 0, that is the initial height. So that could be from the ground, so that would be 0, or it could be assigned a certain height off the ground. Okay, so that's what all the variables there in those equations represent. Okay, let's look at a problem. Kevin hits a baseball at 3 feet above the ground. So that's going to be our y sub 0 is 3. Okay, that's the initial height that he hits it with an initial speed of 150 feet per second. So that is our initial velocity is 150. At an angle of 18 degrees with the horizontal. So that's our theta. Yes. Okay. Okay, so the question is, will the ball clear a 20-foot ball that is 400 feet away? Okay, so we've got to find out when it gets to 400 feet away, is it high enough to get over that wall or not? So let's set up our equations here. Okay, so our x equation is our initial velocity times the cosine of our angle times t. Now, we're not going to work that out right yet. We're just going to leave it. Okay, we're going to leave it the way it is. Okay, our y equation is -16t squared plus our initial velocity times the sine of our angle times t plus our initial height of 3. Okay, so we've got to find out when the ball, or when the wall is 400 feet away. That is the horizontal distance from where he hit it at home plate. So since that's the horizontal distance, we are going to set our horizontal equation, our x equation, equal to 400. We want to know what time is this happening at. So we just divide by the 150 cosine of 18. I know it's kind of a long expression there, but it is just a number. It is just a coefficient. Now, we need to make sure that we are in degree mode, because that angle is in degrees. I am not. I'm in radians right now. So degree mode, 400 divided by parentheses 150 cosine 18. We get that the ball has traveled 400 horizontal feet in 2.804 seconds. Now, For the sake of not losing precision, let's store that as t. I'm in parametric mode, so when I press the X button, it uses t. Okay, I'm going to store that as t, which works out really well because t is what I have in my other equation. The question is, at that time, what's my vertical height? Okay, so plug that into the y equation. Negative 16 t squared plus 150 sine 18 times t plus 3. So I plug t equals 2.804. And I get that y equals 7.178. And this is in feet. The wall is 20 feet tall. So did it clear it? No. It hit the wall at 7.17 feet. So no, it didn't clear. Now, assuming that there was an outfielder close enough to it, would the outfielder have been able to catch that ball? I mean, do you think reasonably an outfielder could catch a ball that's 7 foot high in the air? I would think so. I mean, they'd have to jump just a little bit. But I mean, think about, you know, guy at least 6 foot tall, sticks his arm up. I mean, you're already close to 7 foot or maybe past 7 foot, depending on how tall you are. Okay, so could have caught that ball. Okay, didn't clear the fence, could have caught it if he got in there in time. Okay, what if the initial contact angle is 19 degrees, 20 degrees, 21, or 22 degrees? Let's figure out what degree he needed to make contact with that ball so that he could clear the wall. So we're just going to repeat our calculations here. Okay, 400 divided by 150 cosine 19. Go ahead and store that as t. Okay, that took a little bit longer to get there with just 1 degree difference. Let me save myself some time here. I'm just going to second enter till I get to my equation. Well, that didn't help. It's lower than it was before. Okay, so 19 is out. That didn't clear the wall. How about 20? 400 divided by 150 cosine 20. Okay, took a little bit longer. Store it as t. Plug it into our y equation. Okay, it seems to be getting lower. The higher angle we hit it, which makes sense. Think about it. If you're hitting it, if the angle you're hitting it at is increasing, it's at what?
Because of 150 signs and it's a beat.
Oh, I didn't change that. My bad. I forgot I got to change that part too. Good catch. Let's see if that makes a difference. It might not. Let's see here. Which one did I just do? I just did 20. So let's put sine 20 in there. Forgot that was in the equation, in the other equation. Okay, that helps a little bit. Okay, so I don't know, that I just checked the 20 and we're at 19.7, so I'm thinking that the 19 is still not going to work. 20 still not quite there.
May I have your attention, please? If you're going on the field trip this morning with Ms. Johnson, please report to the front lobby at this time. Thank you.
Not this Miss Johnson, the other one. All right. Let's change it in both equations this time. Okay, so 21 degrees, we're at 2.856 seconds. So we got to plug that in correctly. Let's see here, where are we at? 16 t squared. Okay. Doing 21 degrees times t plus 3. Okay, there we go. 26 feet. Finally, at 21 degrees, we have enough to clear the wall. The time for that is 2.856, and the height ends up being 26.002 feet. So we definitely clear it if it's hit at a 21-degree angle. 19 and 20 were not enough. 18 was not enough. It's amazing how much difference just one little degree can make there. Not changing anything else. The initial velocity is still the same. Distance is still the same, but that just 1 degree incline changes the whole path of the ball. Thank you for